Hey, welcome back to the channel. I'm Merl. I'm so glad you came back. What we are doing is we are going to take this distributor that I have blown apart. It's a GM distributor. It's out of a Corvair. And we're going to turn it into a distributor that still drives the oil pump off the camshaft. And we're going to turn it into a one-tooth cam sensor. So join me as we get at it. I do definitely have a little bit of a conundrum here. I'm not sure what I'm going to do with the cam and crank sensors, and I want to start sizing things up in case I have to order more parts. So hit the easy button on a crank wheel, which I'm going to have to machine something so it fits on here. Bolts on with 2 holes, which is not a big deal at all. And I think I'm going to mount this on here. Now, it should be spaced well. That way that I could potentially, maybe not, but potentially I could, you know, maybe, I don't know. No, I couldn't thread that. I could maybe grind this or make a bracket that bolts onto here that'll hold this hall sensor on. I think that might be a good idea. Just make a little bracket that goes off here to be good and solid. We'll have to get rid of this hold down style if we do that, but we have to modify the distributor. So this is just me thinking out loud. Now, I guess the other conundrum is I'm not sure what this fuel pump drive looks like. So it's just a push rod and it is running on a cam lobe. And it's really neat actually. It is this spring loaded. Wow, look at that. I bet you I can build a bushing that holds this, that has an O-ring in it, and that spring will hold that shaft down. I think I can put this hall sensor up top here and just have this for the cam sensor. Boy, that would be fabulous. I'm just gonna go grab that fuel pump. So definitely we always want to hit the easy button, and I'm just dumping fuel everywhere because I like to. But there's just an O-ring groove on here above that bolt, which I'm not seriously happy about. But I have all the measurements of everything that I need to machine up a piece, and I could throw a double O-ring on it and make it where it bolts in and holds in the same hole as right there with that wedged bolt. And if this housing ever gave way or anything, it wouldn't require anything abnormal if the part needed to be replaced. So I think I'm going to choose to run the hall sensor off the end of that shaft. The only thing is it's got a hollow inside to it, so I might modify the shaft, maybe machine it down to where it's not hollow, depending on how deep it is. No, I can't do that. Maybe I'll weld a little end into it, because yeah, that would make really nice work if I machined a piece that fit in there. It'd be fabulous. Nice little hall sensor there, one there, cam and crank. Keep it simple. Carrying on with the plan, I have completely disassembled the distributor, and nothing surprising in it other than this thing was a massive oil leak. It is completely full of oil, and you can see where at times it was running over the top of this thing. So I'm not sure what the deal is, if it would fill up or whatever, but the points were above it. So the point plate is above that surface. You can see that it was wet there, but the points aren't wet. Now, I definitely, we need to use this to drive the oil pump, but that's all it's going to be. I am going to be machining off the top of this, and I will build a plate that retains it in, and that bolts onto here, and we'll gasket it. And that way this, I mean, it doesn't matter the orientation of it, anything. The one thing that I do believe that I'm going to do, it's okay that this is going to be a little bit bigger with that plate on there. There's a nice surface for there to seal on it and everything. So that's going to be good. But what I want to do is, I definitely do think that, I mean, I could mount the sensor on the other side, but then we're dealing with oil mess underneath the oil filter and stuff. So I think I'm going to utilize either that bolt or the top of this to mount that sensor on here. And so anyway, that's the plan. I think it's going to work out really well. Okay, I have a dial indicator all set up here into where the cam drives. And I thought, you know, I can machine the piece, put it in there. I have lots of movement, so the cam sensor would have worked fine. Then I looked at it again and said, you know what? I think I might have a problem with that. And I'll show you what I mean. If I were to take, which would have worked totally fine, and mount my Hall effect sensor right into here, which would have worked beautifully, would have been no problem at all. Other than I have hot oil running through here. I have all this temperature here. So I looked up to see what was going on with these. And it appears that when these sensors get up to about 165 degrees, they start to fail. So if this was in a hot soak condition, like you shut your vehicle off, temperature spikes, cam sensor out of it, you might have a hard start or a no start. So I'm pulling guts out of here, building a plug to seal this off, and we have to forget about that. I'm sure glad that I second guessed on thinking about this when I was cleaning up the distributor to cut it apart, because I'm going to have to mount this in the distributor, because if I mount it here, I got overheat. If I mount it onto this, at least I'm going to have some air movement around this, and we'll keep it out in the open. The only issue that I have is I have to figure out how I'm going to make this sensor work with without having an oil leak. So this just got a little bit more complicated with the distributor because I have to do some more manufacturing with it. I think I'm going to be okay with figuring that out, but I'm a little disappointed with it because it'd be nice to get rid of that distributor. So we'll figure it out. Glad I decided not to just pull the trigger. I could have had a customer who was not happy with me. I'm very happy I backed up the bus and I didn't wreck this distributor housing, because this is going to make a good cam sensor. Now, first of all, what I want to address is, yeah, this looks like aluminum, and from experience with doing modification stuff before with distributors and stuff like this, there is something you need to realize. It is weldable, but it really sucks to weld. This is pot metal. Doesn't even sound like aluminum. It's you can kind of tell the difference a lot by the sound. Another thing with this is I put it in the lathe to spin it down because I have to figure out a way to seal this because of all the oil coming out. We're going to change this into a cam sensor. I put it in the lathe and this thing, it just flops around weird. So that ain't going to work. This top is not in line with this. So I have to figure out a way to seal this, which I'm pretty sure that ain't going to be a problem. It's just going to take longer. I got to be creative. So plan is I'm going to make a 1-tooth cam sensor. And so I have a piece of C1045 here. I'm just going to use this. I wish I had something lower grade, but it ain't going to matter. It's totally weldable, no problem. So what I'm going to do is I'm going to make this so that it bolts to this plate, and I'm going to machine it down and probably weld on a piece that I CNC out onto this. That's going to be a 1-tooth sensor. We'll get to that. I'll show you that. I went into the back and I found this seal. So this seal is out of a steering rebuild for like a 60 Dart or something like that. I can get that easily, but that's what I got in the back. I don't have to run to town to get it. So I have to, this isn't 1 inch. It's a little bit smaller, which is going to be perfect, but I'm going to be able to seal this whole thing up using a seal on this, which is going to be great because I'm going to be able to contain the oil and not have a big oil leak. And it's okay if there's oil under here because all we're needing is the top of this thing to rotate. So I got to get at that part, but that's what we're doing. Any seal would work, shaft size would work, whatever. And then we will end up mounting the cam the cam sensor close to this somehow on the top plate. So I have to get designing and figure out how I'm going to put this all together. All right, just so a handle of what we got going on here, some detail work. So this used to be, there used to be springs that went on these two little tabs, and this was the centrifugal advance weights, and we're going to eliminate that altogether. We need our computer is going to control all the advance and everything, so we need this shaft to become solid. So what we're going to be doing is we're going to be duplicating this, except that bolts to this plate. So this just slides in and out. That's the drive shaft for it. So we're going to take this and we're going to make this duplicate. So this piece goes over top. We'll have to build a plate that we can weld on, and I'll make it bolt to this. We're going to have to make sure that where it bolts on, the bolt isn't going to hit anything underneath. So that's the first test. I'm going to sample some bolts. There's not an issue though. I know I have them. Then the shaft, we'll get rid of this. We'll have this piece that then slides over top of this, and it's going to be fixed to that. The outer piece of this seal is going to be fitting on, and for right now, that's what I'm going to build, is a piece that this seal will seal and replace this piece. Of course, not everybody has a lathe, so creativity might come in. This piece here, could you modify it so that a seal would work on it? Well, there is, if you could get a seal, I haven't measured it or anything and I don't care. You could potentially get a seal that would fit in this area. You could grind this off, have a seal fit in this area. You'd have to weld this up because it's straight through. And then you could put a drive on top of here, 1-tooth drive or something. All I'm saying is you can get creative. You could just find a piece of tube that fits over top of this and whatever. Get creative. Here's what we came up with, and we needed to make sure that this piece had this recess for the bigger piece here. Now, I drilled it just a hair longer because I want this to sit down, and I'm going to be cutting out a plate that fits around this, and that will bolt onto these bolts. A 1032 screw is tight in here. This one's going to be a little loose. It's fine. We'll be able to make that work, because when this is bolted on, it isn't going to move. And the other thing with this, it's a little bit tighter than the factory piece went on there. So there's zero wobble to this. It's just really, really snug in there, which the original piece probably warm, but it doesn't matter at all. This is a 1-tooth sensor. Once this plate's on here, it ain't going to matter. So I need to machine this down so that it fits the seal now. So what does assuming do? Well, it makes out of me and you. Anyway, I am really happy that I didn't go and machine the shaft down, and I actually looked up the specs for it, and that seal, according to the specs, is actually for a 1-inch shaft. So this is perfect. I'm gonna just polish this up, make sure it looks good. Even though the seal feels really tight, it's meant for this. So what I'm gonna do is I'm gonna take and I'm gonna machine down an area here, leave a sealing surface area, and I am going to take and make something like this. So the top will have the actual, it'll have the actual one tooth on it, and this recessed area will be turned down so that it doesn't interfere with the signal. And the only reason I'm doing that, I could leave that all down. It's just going to be simpler to machine it. So this will have a tooth up top. And then this hole in the top, I don't know what I'm going to do. I think I actually might just take and thread it and put a plug in there, or weld it up, whatever, it doesn't matter. So story now is I am going to take and machine down an area here, machine that down really thin, and then we'll take and machine off that shape. I have the part machined and polished up the shaft so that it'll accept the seal. It fits on there. Now what I want to do is I am going to take the same width, which I haven't measured, as the crank sensor of the tooth, and I'm going to draw it on here. And I was going to set this up in the mill, but all I'm going to do is actually take and grind off what I don't need, clean it up, and it's going to be good. It's going to be faster for me to do that for one piece than setting up the mill to do this. So next step. So this lines, I don't know if you can see them on there, but it's the same width as the tooth on the crank trigger. I measured the distance here, figured it out there. I'm gonna throw it in the lathe and just put a line on it. So I'm gonna hack this thing apart, and I don't want to even come close to the line. So then I can use a file in the end or whatever to clean it up. This dotted section is all gonna be going away. We'll put X's on it. I just love how you can manipulate metal. So that is now the knob on there. I got to take and file up the corners so that it's not sharp. I do want it fairly crispy, but I don't want it where it's like that's sharp as a knife. And I screwed up a little bit. I messed up this edge here, so I have to take and turn it in the lathe again, which really sucks because when I was cutting it, stuff slipped. Sorry. So I'll touch that up and then we'll address the end of this. Well, there we go. There's the top part of the cam sensor. Now I got to build the plate that goes on to the bottom part. I'm very fortunate to have certain tools, but this piece is a piece that I just made. This could be made with just normal hand tools. Fortunately, I have a CNC plasma. I do this kind of thing every day, so you know, the normal person, it doesn't pay to have tools like that. Anyways, so that fits in there beautifully. That's exactly what we're looking for. I'm going to weld it on, and then this is not going to move anywhere. And I'm just by choice going to line up this roughly with the direction of the oil pump drive at the bottom. And then we're going to tack it into place. Now this is extremely tight fit on here. My choice is going to be, I am going to, now that it's tacked, take it off, weld it on the bench, because I don't want to weld this on and find out I unbolted and it's a permanent fixture in case I have to do other mods or something else to it. So the distributor housing, it's quite off. And I'm not going to jig it up to try and center this part. So the dilemma with this is, which really kind of sucks, is this car is like extremely nice. And this was an oil leaker. This is what we're going to be doing instead of a plug. We're going to be using this distributor. So what I'm going to do is I'm going to smooth the inside of this distributor, and I am going to just do it by hand here with emery. And I have figured out some stock, so I have to make a separate top plate, a piece of stock that's going to hold an O-ring, and then that piece that holds the seal. Because nothing's lined up, I need to be able to move it all around with bolt holes, with everything to make it work. So I don't mean to make this marathon. I am not risking an oil leak with this car. So yeah, it's a little extra and whatever, but we're shooting for something that's going to be reliable and high quality. And this is not the quickest, but the best way that I can see how. I don't want this thing, put it this way, you never know when you're redesigning something where a failure might show up. But when you design it and you think about it later on for servicing and so on, a lot of the things you can avoid, and that is the goal, is to do our best to avoid having issues down the road. All right, the inside of this, you can see how really rough texture it is. Well, the whole thing was like that, and now I have the part where I can put an O-ring polished up really nice. I believe that is going to seal and going to be good quality. So I'm going to go ahead and build these parts to get this together. In hopes of speeding this all up, I'm just going to take you step by step what I did. So you saw me finish polishing this. I found an O-ring that fits in here beautifully. I keep quite an inventory O-rings in the back. So this fits in there really nice. Then I took a piece of pipe and I machined that pipe off. It's just a piece of pipe. And I made an O-ring groove in it for this O-ring. So when this O-ring goes on, now this, when it gets pushed in, is going to be a really nice fit. The O-ring tolerance is really tight. I had to have the O-ring just below this and above this. So this now will fit in there, and it'll be just below and just above. It's going to work out perfectly for what we're doing. Okay. Then what I did is I took and plasma cut this out. So this can go in, and this, now I have these holes here where I can tack through from the top. So when I bolt this together, these holes are all sloppy, so it can move around, and this can move around independently. And then I took another piece of stock and I machined it down. Now the seal is gonna fit in here and this goes on here. So I can weld this 100%. And because this is offset, this can go on here. I'll mark it and have it so that it only fits one way. And this will be welded underneath there. So all of this, if it goes in the same direction, will take up the slop from this thing not being true to the shaft that goes through it. And we will have a beautifully put together piece. I just have a piece of scrap here from by the shear. It happens to fit exactly tight in there. What I'm going to do is I'm just going to tack it on, zip off the rest, and that will give my location of this piece so that it always goes on the exact same way. So I've left that O-ring in there to keep it all centered and everything. This thing's turned out perfect. Just gonna tack this in, then I'm gonna have to take it apart, weld it all out, and the O-ring that's in there will, like, just from tacking it, it's gonna be garbage. So just from tacking her up, it is completely melted the O-ring. But now I got a nice piece. It's a one piece. I'll weld it all out and we'll have a very nice sealed cam sensor. Still have to build the sensor mount. Okay, she's hotter than a firecracker. She's welded out and inside is welded out. This thing won't be able to leak oil. I'm gonna put it together dry without the seals in. We can run the engine and everything like this. It just wouldn't be good long term, but now I have a top of this thing that is totally sealed up. And she's gonna be not leaking oil. And we won't be reusing that O-ring. Trigger wheel for the cam sensor is sitting in the engine. It's gonna look pretty good in there. I think we'll powder coat it up. It'll look really pretty. But the cam sensor itself now, I am going to have to build a mount. I think I'm gonna use maybe 2-3 bolts off of here. This needs to be stable so it doesn't vibrate. So I am going to come up with something, probably CNC out a bracket that this can come out of, and as well that is adjustable on here so that this we can adjust the gap on. And then for getting fine tune adjustments, well, we can just use the original distributor to rotate this, as well as we can offset it in the computer, and we'll get to that when we get to that. I CNC'd out this bracket, and anyway, I just took and machined these pieces, CNC'd them. You wouldn't have to use a CNC, and this wouldn't have to be this adjustable. On this one, it was easy to make adjustable, so that's exactly what I did. And the sensor's in there right now. We'll have to rotate the engine, set it up, but eventually this is all got to come apart and get powder coated anyways. But she's turning out good. Thanks for joining me in this video building this cam sensor, and hopefully it gave you some ideas for a DIY fuel injection. I'm pretty happy with how it turned out. We'll see when I get this thing running with the seal in and it all coated up and everything. It should be great. So thanks for watching. Please like, share, and subscribe.